So guys, today's first session is scheduled for binomial theorem and second session is for a straight line. Is it clearly visible to you, Karishma? Okay. An expression containing two terms is called a binomial. The power series expansion of a binomial is called binomial theorem. All of you know x plus a 2 raised to the power 0 is equal to 1. X plus a raised to the power 1 is equal to x plus a. X plus a raised to the power 2 is equal to x square plus 2xa plus a square. X plus a raised to the power 3 x cube plus 3x square a plus 3x square plus of a cube x plus a raised to the power 4 is equal to x to the power 4 plus 4x cube a plus 6 x square plus 4x a cube plus a to the power 4. Okay. Then x plus a raised to the power 5 x to the power 5 plus 5x to the power 4 plus a into a plus 10 x cube a square plus 10 x square a cube plus 5x a to the power 4 plus a to the power 5. Okay. So, the power series expansion up to x plus a to the power whole cube. So, x plus a to the power 4, x plus a to the power 5, x plus a to the power 6, anything you can write. If you can observe the pattern in which the series is expanded. So, first pattern is if the exponent or power of the binomial is 0, then the number of terms is 1. If the exponent is 1, then the number of terms is 2. If the exponent is 2, the number of terms is 3. If the exponent is 3, number of terms is 4. So from this, it is clear that if the exponent or power of the binomial is n, then the number of terms in the expansion is n plus 1. Okay, this is the... Then secondary, in each term of the expansion, sum of the powers of x and a is equal to power of the binomial. Let's go through the power expansion of x plus a to the power 3. The first term, it is x cube. So power of x is 3, a is absent. That means power of a is 0. 3 plus 0 is 3. In the second term of the expansion, the power of x is 2, power of a is 1. 2 plus 1 is equal to 3. In the third term of the expansion, power of x is equal to 1. Power of a is equal to 2. 2 plus 1, 3. In the last term, power x is absent means power of x is 0. Power of A is 3, 0 plus 3 is 3. Okay. If we move from left to right, in any of the expansion, power of x decreases by 1 and power of a increases by 1. So keeping all these facts in mind, we can write the power expansion of a, suppose we want to write the expansion of x plus a to the power 7. Without a coefficient, we can write the expansion x to the power 7. The next term, power of x will decrease by 1 and the power of a will decrease by 1. So x to the power 6 a. The next term will be x to the power 5 a square. Next term will be x to the power 4 a cube. Next term x cube a to the power 4. Then the next term will be x square a to the power 5, x a to the power 6 plus a to the power 7. Okay. The coefficients also follow a definite pattern. If you can judge the pattern, then you can write the power expansion of x plus a, any power expansion of x plus a. You see, when the coefficient exponent is 0, the expansion contains only one term and its coefficient is 1. When the exponent is 1, there are two terms, the coefficients are 1 and 1. When exponent is 2, there are three terms, coefficients are 1, 2, 1. Write down exponent and coefficient. If the exponent is 0, there is only one term, its coefficient is 1. If the exponent is 1, there are two terms, coefficients are 1 and 1. If the exponent is 2, the coefficients are 1, 1 plus 1, 2, then 1. Coefficient of the first term and last term must be 1. The exponent is 3, 1, 2 plus 1, 3, 2 plus 1, 3, again 1. If the exponent is 4, 1, 3 plus 3, 6, 3 plus 1, 4, again 1. Sorry. Okay. So this is the pattern of the coefficients in the expansion. So using this pattern, we can write the expansion of any power of x plus a. But practically, it is not possible if the question is find the power expansion of x plus a to the power 100. Then this is called Pascal's triangle. So we have to write the Pascal's triangle in short form. If the exponent is 0, coefficient is 1, this can be written as 0 C0. If the exponent is 1, the two coefficients 1 and 1, one will be 1 C0 and the second one is 1 C1. If the exponent is 2, then the coefficients are 2 C0, 2 C1, 2 C2. If the exponent is 3, the coefficients are 3 C0, 3 C1, 3 C2, and 3 C3. If the exponent is 4, the coefficients are 4 C0, 4 C1, 4 C2, 4 C3, 4 C4. Similarly, if the exponent of the binomial is n, then the coefficients are from NC0 to NCn. NC0, NC1, NC2, up to NCn. I hope it is clear to you. Is it clear? Karishma, Anveshan? Okay, guys, quickly note it down. I'll go to the next page. S plus a to the power n is equal to nc0 x to the power n plus nc1 x to the power n minus 1 a to the power 1 plus nc2 x to the power n minus 2 a to the power 2 plus up to ncr x to the power n minus r a to the power r plus up to ncn x a to the power n. The above series expansion is called binomial theorem. The above series expansion is called binomial theorem. So x plus a to the power n in summation form we can write it as sigma r is equal to 0 to n ncr x raised to the power n minus r a raised to the power r. If you take r is equal to 0, then you will get the first term, that is nc0 x to the power n minus 0 a to the power 0. If you take r is equal to 1, you will get the second term, that is nc1 x to the power n minus 1 a to the power 1. For r is equal to 2, you will get the third term, nc2 x to the power n minus 2 a to the power 2, and so on. So replacing a by minus a, negative a, in the above expansion, we will get the expansion of x minus a to the power n. Replacing ତିନିଟା ଏଇଠି ମୋ ପାଖକୁ ନେଇ ଆସ। nc0 x to the power n minus nc1 x to the power n minus 1 Yes, Karishma, video is not clear. Hello, write in the chat box. Okay, just a minute, just a minute. Is it clear now? Rajashri, is it clear? So x minus a raised to the power n is equal to nc0, x to the power n minus nc1, x to the power n minus 1, a to the power 1, plus nc2, x to the power n minus 2, a to the power 2, then minus up to minus 1 raised to the power n, ncn, a raised to the power n. So in summation form, we can write x minus a raised to the power n equals to sigma r is equal to 0 to n minus 1 raised to the power r ncr x to the power n minus r a to the power r. Okay. Then write down some facts about binomial theorem. Fact 1. If the exponent or the power if the exponent or the power of the binomial is n, then the number of terms in the expansion is n plus 1. If the exponent or power of the binomial is n, then the number of terms in the expansion is n plus 1. That means if the exponent is 5, then the expansion will contain 6 terms. If the exponent is 6, then the expansion will contain 7 terms, right? Fact number 2, in each term of the expansion, in each term of the expansion, sum of the powers of x and a is equal to power of the binomial. In each term of the expansion, sum of the powers of x and a is equal to power of the binomial. Terms equidistant from beginning and end terms equidistant from beginning and end have same coefficients and the fact is NCR is equal to NCN minus R. Is it clear? Is it clear, guys? Write in the chat box. Okay, fact number 3, yes, I can explain it again. The fact number 3 is terms equidistant from beginning and end have same coefficient. Let me write one of the expansion so that you can understand easily. Okay. So take the example of x plus a raised to the power 4. For C0, x to the power 4, for C1, x cube a, for C2, x square a square, for C3, x a to the power 4, for x a cube, for C4, a to the power 4. So what is the coefficient of the term from the beginning? First term from the beginning is 4C0 and coefficient of the first term from the end is 4C4. You know 4C0 is equal to 4C4. So coefficient of the second term from the beginning is 4C1. Coefficient of the second term from the end is 4C3. 4C1 is equal to 4C3. Clear? 4C0 is equal to 1. 4C4 is equal to 1. 4C1 is equal to 4. 4C3 is equal to 4. Karishma, did you understand? Write in the chat box. Is it clear? Okay. Before going to fact number 4, let's come to the expansion of x plus a raised to the power n. X plus a raised to the power n is nc0, x to the power n plus nc1, x to the power n minus 1, a to the power 1, nc2, x to the power n minus 2, a to the power 2, plus up to ncn, a raised to the power n. You see, nc0 is the first term, nc1 is the second term, nc2 is the third term. So first term, third term, fifth term, seventh term, these are called odd place terms. Second term, fourth term, sixth term, these are called even place terms. So coefficients of odd place terms are NC0, NC2, NC4, and so on. Coefficients of even place terms are NC1, NC3, NC5. Okay. Come to fact number 4. If the exponent n is even, then the number of terms n plus 1 is odd. If the exponent n is even, then the number of terms n plus 1 is odd, which implies number of odd place terms is one more than number of even place terms. Okay. So total number of terms is n plus 1. So number of odd place terms is one more than number of even place terms. So number of odd place terms will be is equal to n by 2 plus 1, and the number of even place terms is equal to n by 2. Okay. Fact number 5. If the exponent n is odd, if the exponent n is odd, then the number of terms n plus 1 is even, thus number of odd place terms is equal to number of even place terms equals n plus 1 by 2. Is it clear to you? Did you understand, guys? Okay, let's move forward. So x plus a raised to the power n equals to nc0 x to the power n plus nc1 x to the power n minus 1 a to the power 1 nc2 x to the power n minus 2 a to the power 2 plus up to ncr x to the power n minus r a to the power r plus up to ncn a to the power n. Okay. This is the series expansion of x plus a raised to the power n. nc0 is first term, nc1 second term, nc2 third term. Similarly, ncr will be r plus 1th term. And ncn will be n plus 1th term. Clear? In summation form, this expansion is written as x plus a to the power n is equal to sigma r is equal to 0 to n ncr x to the power n minus r a to the power r. If you take r is equal to 0, you will get the first term, that will be nc0 x to the power n. For r is equal to 1, we will get the second term, that is nc1 x to the power n minus 1 a to the power 1. For r is equal to 2, we will get the third term. So this term ncr x to the power n minus r a to the power r will give you the different terms of the expansion for different values of r. So this term is known as general term or generating term. So write down general term in the expansion of x plus a to the power n is tr plus 1, that is ncr x raised to the power n minus r a raised to the power r. Okay. Let us come to discuss couple of questions on the theory discussed now. Question number 1. Find the expansion of 2x plus 3y whole to the power 5. So here x is equal to 2x, a is equal to 3y, this is equal to 5c0, 2x raised to the power 5 plus 5c1, 2x raised to the power 5 minus 1, that is 4, into 3y raised to the power 1 plus 5c2, 2x raised to the power 3 into 3y raised to the power 2 plus 5c3, 2x raised to the power 4, 3y raised to the power, 2x raised to the power 2, 3y raised to the power 3 plus 5c4, 2x raised to the power 1, 3y raised to the power 4 plus 5c5, 3y raised to the power 5. Okay. This is the expansion of 2x plus 3y raised to the power 5. Next question. Is it clear to you? Did you understand, guys? Write in the chat box. Is it clear? Okay, question number 2. Find the fifth term in the expansion of find the fifth term in the expansion of 2x square plus 3 upon x raised to the power 11. Okay. We have to find the fifth term t5. T5 can be written as t4 plus 1. You know, tr plus 1 is equal to ncr, x to the power n minus r, a to the power r. So t4 plus 1 is equal to what is n? N is equal to 11. 11c4. Here in place of 2x square is there. 2x square to the power 11 minus 4 into 3 upon x raised to the power 4. This is equal to 11c4, 2 raised to the power 7, x square raised to the power 7 will be x to the power 14 into 3 raised to the power 4 upon x raised to the power 4. This is equal to 11c4, 2 to the power 7 into 3 to the power 4 into x to the power 10. Is it clear, Karishma? Okay. Then the next question. Find the term independent of x in the expansion of term independent of x means the term which doesn't contain any power of x, that is power of x will be 0. Try to solve it. Let tr plus 1 be r plus 1 is equal to 9 cr 2x raised to the power 9 minus r 3 upon x square raised to the power r x raised to the power minus 2r. This is equal to 9 cr 2 raised to the power 9 minus r 3 raised to the power r x raised to the power 9 minus r plus minus 2r, that will be 9 minus 3r. Since the term is independent of x, the power of x will be 0. 9 minus 3r is equal to 0. 3r is equal to 9. R is equal to 9 upon 3, which is equal to 3. Thus, 9c3 2 to the power 6 into 3 to the power 3 is the term in the expansion of is it clear? Okay, next question. Next question, find the number of rational terms in the expansion of square root of 2 plus cube root of 3 raised to the power 12. This is the question, try to answer. Find the number of rational terms in the expansion of square root of 2 plus cube root of 3 raised to the power 12. Try to answer this question. How to find the number of rational terms? Let TR plus 1 be a rational term. TR plus 1 is equal to NCR, that is 12 CR, square root of 2 to the power, 12 minus R into cube root of 3 raised to the power R. Okay. The term will be a rational term if 12 minus R should be a multiple of 2 and R should be a multiple of 3. So R should be a multiple of 2 and 3, that is a multiple of 6. So above term will be a rational term it is square root ଅଛି square root हटिया दरकार एटी क्यूब रूट हटिया दरकार स्क्वायर रूट हटिया पई ए 12 माइनस r टा मल्टीपल ऑफ 2 होवा दरकार क्यूब रूट हटिया पई r टा मल्टीपल ऑफ 3 होवा दरकार ताले बोथ स्क्वायर रूट और क्यूब रूट हटिया पई r शुड बी मल्टीपल ऑफ 3 मल्टीपल ऑफ 6. So we can take r is equal to 0 or r is equal to 6 or r is equal to 12. Thus there are three rational terms. Okay. Is it clear? Karishma, Rajashri, Anveshan? Sweetie, no sir. Should I explain it again, Sweetie? Okay, let me explain it again. Number of rational terms in the expansion of square root of 2 plus cube root of 3 whole to the power 12. Let us assume TR plus 1, that is 12 CR, square root of 2 to the power 12 minus R, cube root of 3 to the power R is a rational term. The term will be rational term if root over of 2, root over of 2 टाक आमे हटै परिबा क्यूब रूट टाक हटै परिबा, then it will be rational term. It is square root हटिया पई 12 minus r should be a multiple of 2 and cube root हटिया पई r should be a multiple of 3. Then r should be a multiple of 2 as well as multiple of 3. So r should be a multiple of 6. Sweetie, did you understand what I mean to say? ଯଦି ଏଇଟା ଗୋଟେ r 12 ମାଇନସ୍ r ଟା 2 ର ମଲ୍ଟିପୁଲ ହେଇଯିବ ଏଠି ସ୍କୋୟାର ରୁଟ୍ ହଟିଯିବ। ଯଦି ଏଠି r ଟା କଣ ମଲ୍ଟିପୁଲ ଅଫ 3 ହେଇଯିବ ଏଠି କ୍ୟୁବ ରୁଟ୍ ହଟିବ। ତାହେଲେ ସ୍କୋୟାର ରୁଟ୍ କ୍ୟୁବ ରୁଟ୍ ହଟିଲେ ହିଁ ରାସନାଲ ଟର୍ମ ହବ। ତାହେଲେ r should be a multiple of 6। r ଯଦି ମଲ୍ଟିପୁଲ ଅଫ 6 ହବ ତାହେଲେ r ର ପସିବଲ ଭ୍ୟାଲୁ କଣ ହବା ଦରକାର? r is equal to 0 ହେଲେ ହେଇପାରିବ, r is equal to 6 ହେଲେ ହେଇପାରିବ, r is equal to 12 ହେଲେ ହେଇପାରିବ। Clear? So there are three rational terms. So is it clear now? Karishma? Rajashree, is it clear? Okay. Then come to middle term or terms in a binomial expansion. X plus a raised to the power n is equal to nc0 x to the power n plus nc1 plus nc2 x to the power n minus 2 a to the power 2 plus up to ncn a to the power n. If n is even, then the number of terms n plus 1 is odd. Thus, the expansion contains only one middle term. If n is even, then the number of terms n plus 1 is odd. Thus, the expansion contains only one middle term. The middle term will be total number of terms is n plus 1. One middle term is there. Okay. Then, except this middle term, n terms will be there. So, n by 2 terms will be in the left hand side of middle term and n by 2 terms will be in the right side of middle term. So, the middle term is, thus the middle term is T n by 2 plus 1. So T n by 2 plus 1, Tr plus 1 is equal to Nc n by 2 into x raised to the power n minus n by 2 a raised to the power n by 2. Tr plus 1 is equal to Ncr x to the power n minus r a to the power r. This is equal to Nc, sorry, Nc n by 2 x raised to the power n by 2 a raised to the power n by 2. Okay. If n is even, then come to if n is odd, then the expansion contains two middle terms. If n is odd, then the expansion contains two middle terms. The middle terms are, so total number of terms is n plus 1, out of which two terms are middle terms. So out of the rest terms, half of the terms will be the left hand side of the middle terms, and half of the terms will be in the right hand side of the middle term. So rest of the terms, except the middle term, rest of the terms is n minus 1. N minus 1 by 2 terms will be in the left, and n minus 1 by 2 terms will be in the right. So the middle terms are one of the middle term will be Tn minus 1 by 2 plus 1, and the second one will be Tn minus 1 by 2 plus 1 plus 1. Guys, quickly note it down. Okay. To the two middle terms are Tn minus 1 by 2 plus 1. So Tr plus 1 is equal to NCr, NC n minus 1 by 2, x raised to the power n minus 1 by 2 a raised to the power n minus 1 by 2. And the second middle term is Tn minus 1 by 2 plus 1 plus of 1. This is equal to Tn plus 1 by 2 plus 1. This is equal to Nc n plus 1 by 2 x raised to the power n minus n plus 1 by 2 a raised to the power n plus 1 by 2. In return the question, find the middle terms in the following expansion. Like to answer these questions. 2x plus 3y raised to the power 10. Here the exponent or power of the binomial is even. So the expansion will contain only one middle term. Total number of terms is 11. So the middle term is sixth term T6 is equal to T5 plus 1 is equal to 10C5 2x raised to the power 10 minus 5 and 3 upon y raised to the power 5. This is equal to 10C5 2 to the power 5 into 3 to the power 5 x to the power 5 into y to the power minus 5. This is the middle term. Okay. Come to second question. 4x square plus 2 upon x raised to the power 9. Here the exponent of the binomial is odd. So number of terms is even and number of terms is 10. The expansion contains two middle terms. The middle terms are fifth term and sixth term. So T5 equals T4 plus 1. That is 9C4 9C4 4 to the power 5 2 to the power 4 x to the power 10 by x to the power 4. That will be x to the power 6. Is it clear? Annesham, is it clear? Rajashri, then the next middle term is T6. Pankaj, is it clear? Pankaj, today you are late. So guys, today's first session is over. Now we'll start the second session. Second session is scheduled for coordinate geometry, that is straight line. Okay. In the last session, I have already finished points. Today we'll start the straight line. Locus, all these things, angle between two lines. Write down area of triangle. If A x1 y1, B x2 y2, C x3 y3, be the vertices of a triangle ABC, then area of triangle ABC is given by delta is equal to half of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. In the another form, in the determinant form, is a delta is equal to half of x1 y1 1, x2 y2 1, and x3 y3 1. So In another form also, we can find the area delta is equal to half of, this is called determinant form. X1, Y1, X2, Y2, X3, Y3, just a minute. Again, X1, Y1. The value will be equal to X1, Y2 minus X2, Y1, X2, Y3 minus X3, Y2, X3, Y1 minus X1, Y3. So downward arrow positive, upward arrow negative. So if you want to expand it, the value will be half of X1, Y2 minus X2, Y1 plus X2, Y3 minus X3, Y2 minus X1, Y3. So come to the proof. Coordinates of A are x1, y1. Coordinates of point B are x2, y2. Coordinates of point C are x3, y3. Right? Draw perpendiculars from point A, B, C upon x-axis. Let PQR be the feet of the perpendiculars drawn from the points A, B, C. Okay. So coordinates of point B are x2, y2. So P length is x2, P length is y2. Coordinates of point A are x1, y1. So Q length is x1 and AQ length is y1. Coordinates of point C are x3, y3. So OQ length is x3. RC length is y3. So the length PQ will be x1 minus x2. Length QR is equal to x3 minus x1. Okay. So area of triangle ABC equals to area of trapezium ABPQ plus area of trapezium AQRC minus area of trapezium BCRP. Okay. What is the formula to find the area of trapezium? Area of trapezium is equal to half sum of the parallel sides into height. So area of trapezium ABPQ is equal to half of length of parallel sides y1 plus y2 or y2 plus y1 into height. Height is the distance between the parallel sides, that's x1 minus x2 plus half of area of trapezium AQRC y1 plus y3 into x3 minus x1 plus, sorry, this is minus area of the trapezium BCRP y2 plus y3 into x3 minus x2. Okay. So after simplification, this one will be Clear? 3 points Qx1 y1, Qx2 y2, and Rx3 y3 are collinear. 3 points Px1 y1, Qx2 y2, and Rx3 y3 are collinear if 3 points are collinear means they can form a triangle. So area of the triangle will be 0. X1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 is equal to 0. Question, Kathleen? And the area of the triangle which vertices are Sir, namaskar. And the area of the triangle whose vertices are 1, 5, 2, 2, and 4, minus 1. Delta, this is x1, y1. Consider these two as x2, y2. And the last pair as x3, y3. Delta is equal to half of x1, 1 into y2 minus y3, 2 minus of minus 1, plus x2 that is 2 into y3 minus y1, minus 1 minus 5, plus x3 that is 4 into y1 minus y2, 5 minus 2. Since area can never be negative, we have to take the absolute value. So half of 1 into 3 is 3, 2 into minus 6 is minus 12, 4 into 3 is 12. Best of luck. This is equal to 3 by 2 square units. Okay. Next question. If x1, x2, x3 and y1, y2, y3 are in a P, then show that the points x1, y1, x2, y2 and x3, y3 are collinear. If x1, x2, x3 and y1, y2, y3 are in a P, then show that the points are collinear. To prove the points are collinear, it is enough to show that area of the triangle found by joining these points is 0. Okay. So x1, x2, x3 are in a P and y1, y2, y3 are also in a P. So x1, x2, x3 are in a P. This implies x2 is equal to x1 plus d and x3 is equal to x1 plus 2d. Similarly, y1, y2, y3 are in a P implies y2 is equal to y1 plus d, y3 is equal to y1 plus 2d. So area of the triangle is delta is equal to half of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. x1, y2 is y1 plus d, y3 is y1 plus 2d. So y1 plus d minus y1 minus 2d, x2 is x1 plus d into y3 minus y1, y1 plus 2d minus y1 plus x3 is x1 plus 2d into y1 minus y2, so y1 minus y1 minus d. This is equal to half of x1 into plus 1 minus y1 cancels, d minus 2d, that is minus d, plus x1 plus d into 2d plus x1 plus 2d into minus d. This is equal to half of minus x1 into d plus x1 into 2d plus 2d square minus x1 into d minus 2d square plus 2d square minus 2d square cancels, minus x1d minus x1d minus 2x1d plus 2x1d cancels. This is equal to half into 0 is equal to 0. This implies points are collinear. Okay. I hope it is clear to you. Then come to inclination of a line. The angle theta made by a line with positive direction of x-axis in anticlockwise sense is called inclination of the line. Okay. Suppose this is your coordinate system. There is a line L. This angle theta is the inclination of the line. And then a note point. If theta is acute, line is inclined towards positive direction of x-axis. If theta is obtuse, line is inclined towards negative direction of x-axis. Third note point, if theta be the inclination of line, then theta belongs to 0 to pi. If theta is equal to 0, line is parallel to x-axis, if theta is equal to pi by 2, line is perpendicular to x-axis, not 0.4, inclination of a line determines the direction of the line. Guys, please wait for a minute. Did you understand? Write in the chat box. Is it clear to you? Then come to slope or gradient of line. Write on the trigonometrical tangent of angle of inclination the trigonometrical tangent of angle of inclination of a line is called slope or gradient of the line. जल्दी लिखिए अपने नेक्स्ट पेज को ଯିବା। If theta be the inclination of the line, then tan theta is equal to slope, and it is denoted by m. M equals tan theta. If theta is equal to 0 degree, implies slope m is equal to tan 0 is equal to 0. Theta is equal to 45 degree. Slope m is equal to tan 45. Tan 45 is equal to 1. Theta is equal to 60 degree. M is equal to tan 60. Tan 60 is equal to root 3. Theta is equal to 145 degree. Slope m is equal to tan 145 degree. That is negative 1. Okay. Then come to slope by 2-point formula. Then slope of the line segment joining two given points Px1 y1 and Qx2 y2 is given by y2 minus y1 upon x2 minus x1, otherwise known as rise over run. Okay, come to the explanation. Suppose this is point P and this is point Q. Coordinates of point P are x1, y1. Coordinates of point Q are x2, y2. Let M and N be the foot of the perpendiculars drawn from P and Q upon x-axis respectively. Since coordinates of point P are x1, y1, then length OM is x1 and length PM is y1. And draw a perpendicular from point P upon QN. Let R be the foot of the perpendicular. Since PM length is y1, then length Rn is also y1. Coordinates of point Q are x2, y2. So length ON is x2 and length QN is y2. Okay. So length Mn will be ON minus OM. That is x2 minus x1. So Mn is equal to PR. PR is equal to x2 minus x1. So QR will be y2 minus y1. Okay. Let this angle be theta. That is the inclination of the line. So PR and x-axis are parallel and this is the transversal. So this angle must be equal to theta. We have to find slope, that means tan theta in the triangle PQR. Tan theta is equal to QR upon PR, that is y2 minus y1 upon x2 minus x1. Okay, is it clear? Write down a question. Find the slope of the line joining the points Consider this one as x1, y1 and this pair as x2, y2. Slope is y2 minus y1 upon x2 minus x1. That is 4 minus of minus 1 upon 3 minus 2. This is equal to 5 by 1, which is equal to 5. Okay. Then come to angle between two lines. The angle theta between two lines having slopes m1 and m2 is given by theta is equal to tan inverse m1 minus m2 upon Come to the proof. This is suppose line L1. This is line L2. Let slope of line L1 be M1 and slope of line L2 be M2. Let θ1 and θ2 be the inclinations of the lines L1 and L2 respectively. Thus tan θ1 will be, or tan θ1 is equal to M1 and tan θ2 is equal to M2, and this, let this angle be theta, then this angle will be theta, vertically opposite angle. So exterior angle is the sum of the interior angles, external internal angles. Okay, so θ1 is equal to θ2 plus of theta. This implies theta is equal to θ1 minus θ2. Taking tan of both sides, tan theta is equal to tan of θ1 minus θ2. Okay, tan A minus B formula. Tan A minus tan B by 1 plus tan A tan B. Tan θ1 minus tan θ2 upon 1 plus tan θ1 into tan θ2. Tan θ1 is M1. Tan theta is equal to M1 minus M2 upon 1 plus M1 M2. So theta is equal to tan inverse M1 minus M2 upon 1 plus M1 M2. ଲେକ୍ଚର ଲା ପ୍ଲେ ନେକ୍ସଟ ପେଜ ଯିବା, ଜଲ୍ଦି ଜଲ୍ଦି ଲେଖିଦିଅ। Then come to special cases. case 1, theta is equal to 0 degree. That means lines are parallel. If two lines are parallel, then what is the relation between their slopes? Okay. So we have tan theta is equal to m1 minus m2 upon 1 plus m1 m2. So substitute theta is equal to 0. So tan 0 is equal to m1 minus m2 upon 1 plus m1 m2. The value of tan 0 is 0. 0 equals m1 minus m2 upon 1 plus m1 m2. So m1 minus m2 is equal to 0. This implies m1 is equal to m2. Thus two lines are parallel. If and only if their slopes are equal. Then come to case 2, theta is equal to 90 degree. Lines are perpendicular. Lines are perpendicular. So tan theta is equal to m1 minus m2 upon 1 plus m1 m2. Now substitute theta is equal to 90 degree. So tan 90 is equal to m1 minus m2 upon 1 plus m1 m2. You know the value of tan 90 doesn't exist. So you have to take cot 90. The value of cot 90 is 0. Those two lines are perpendicular. If product of their slopes is minus 1. That means if the slope of this line is 2 and this is then slope of the perpendicular line will be minus 1 by 2. Okay, did you understand? In the last class, I had told you, using the slope concept, we will be able to get the coordinates of orthocenter of a triangle, right? So we'll discuss a couple of questions on orthocenter by using slope concept. Question: find the coordinates of orthocenter of a triangle whose vertices are 0, 0, 4, 0, and 3, 4. And the coordinates of orthocenter of a triangle whose vertices are 0, 0, 4, 0, and 3, 4. This is 0, 0, 4, 0. This is 3, 4. Okay. We have to find the coordinates of orthocenter. You know, altitudes of a triangle are concurrent, and the point of concurrence is called the orthocenter of the triangle. Okay. So if you draw a perpendicular from point 3, 4 upon x-axis, so orthocenter will be on this line. You see, since coordinates of this point are 3, 4, this length is 3 unit. If you take any point on this line, its x coordinate will be 3. So from this, it is clear that x coordinate of the orthocenter must be equal to 3. Okay. So if you drop a perpendicular from origin, suppose this is O, this is A, this is B. Now drop a perpendicular from origin upon a B. This is another altitude. This is the first altitude. These two altitudes meet at this point. So eventually the third altitude must pass through this point. This is the orthocenter of the triangle. Since the coordinates of point A are 3, 4, if you take any line on this line, any point on this line, its x coordinate will be 3. So x coordinate of orthocenter is 3. Let the y coordinate be y. This is suppose point P. Okay. I'm writing it separately. So coordinates of point P are 3, y. Coordinates of this point are 3, y. So this line is perpendicular, OP is perpendicular to AB. OP perpendicular to AB. This implies slope of OP into slope of AB is equal to -1. Slope of OP into slope of AB is equal to -1. The slope of OP, coordinates of O are 0, 0. Coordinates of P are 3, y. By 2-point formula, we can get the coordinates of OP. That is y minus 0 upon 3 minus 0 into slope of AB. That is 4 minus 0 upon 3 minus 4 is equal to -1. This implies y upon 3 into 4 upon -1, that's -4, is equal to -1. So y is equal to क्या वो ऑनलाइन क्लास so y upon 3 into -4 is equal to -1. Minus minus cancels. So y is equal to 3 upon 4. Thus coordinates of orthocenter are 3, 3/4. I hope it is clear to you. Then come to locus and its equation. Locus and its equation. Write down locus. The path traced out by a point which moves in a plane obeying certain geometrical condition or conditions is called locus of the point. The path traced out by a point which moves in a plane obeying certain geometrical condition or conditions is called the locus of the point. जल्दी लिखी दिया प्ले नेक्स्ट पेज जीवा Come to some examples on locus. Example 1. A point moves in a plane in such a way that its distance from a fixed point always remains same. Then the locus of the point is a circle. If a point moves in a plane in such a way that its distance from a fixed point always remains same, then the locus of the point is a circle. Suppose this is the fixed point. C and P be a variable point. Okay, the point P, variable point means constantly changing its direction and position. The constraint on point P is whatever may be the position of point P, its distance from point C is always fixed. Let the distance be R unit. So the point P will move like this. So the path made by the point P is a circle. So locus is a circle. Okay. Example 2. Let capital A and capital B be two fixed points and P be a variable point such that PA is equal to PB. Let A and B be two fixed points and P be a variable point such that PA is equal to PB. Then the locus of P is a straight line which is the perpendicular bisector of the line segment joining A and B. If the point P is at this position, then PA is equal to PB, from class 9 theorem. Perpendicular point on perpendicular bisector is equidistant from the endpoints. So if you take point P here, then PA is equal to PB. The point P will move on this line, and so the locus of the point P is the straight line, which is the perpendicular bisector of the points joining A and B. Okay. Malay, is it clear? Malay. ବିଜୟ ସାର୍ ପିଲାମାନଙ୍କୁ ଆଉ ବ୍ରେକ୍ ଦିଆଯାଉନି ଯୋଉ ଦିଟା ସେସନ ରହୁଛି 7:30 to 9, 9:15 to 10:45 ଏବେ DHS ରୁ ଅଛି କ୍ଲାସ୍ ବ୍ରେକ୍ ଦେଲେ ପିଲା ଡ୍ରପ୍ ହେଇଯାଉଛନ୍ତି ତେଣୁ ବ୍ରେକ୍ ଆଉ ଦିଆଯାଉନି 9 ରୁ ଷ୍ଟାର୍ଟ ହେଇଯାଉଛି କ୍ଲାସ୍। We have done equation to locus. Is the algebraic representation of the geometrical condition satisfied by the moving point. Equation to locus is the algebraic representation of the geometrical condition satisfied by the moving point. Okay. Or it is the relation between the ordinate and abscissa of each and every point lying on the locus. Let me explain it through an example. Find the equation to locus of a point which moves in a plane and the equation to locus of a point which moves in a plane in such a way that its distance from 0, 0 is 5 units. Okay. Just before I told you, the locus will be a circle if a point moves in a plane, maintaining a fixed distance from a fixed point. Okay, then the locus will be a circle. We have to find out equation of this circle. Okay. The C point is 0, 0. P is a variable point. Let the coordinates of the variable point is x comma y. Thus distance CP is 5 unit. CP is equal to 5. This implies CP square is equal to 25. This implies x square plus y square is equal to 25. Okay. Okay, guys, this is all about your locus. So rest of the straight line portion will be discussed in the next schedule. Okay. DJ sir, Royal Namaskar.